Hi, and welcome to the poster presentation of Modeling of a Motorized Gimbal System. My name is Daniel Similä, and I'm a mechanical engineering student in my last year, studying mechatronics.
And my name is Tim Wiik, studying my last year in applied physics and electrical engineering, with a master within control and information systems.
The project we made was a collaboration between Nordic and LINK-SIC. Nordic is a company based here in Linköping, which products consist of camera stabilization systems and control units. The project this year revolved around their main product, the camera stabilizing head, Newton, and the overall aim was to improve their models and control of their system. This system can be seen in the figure to the left.
And the model's purpose is to translate an applied torque to a rotational speed in order to predict the system's movements. To model this system, we first assumed that each axis can be modeled separately and began with the horizontal pan axis, where we concluded that an inertia and a simple friction model consisting of a static and a linear term was sufficient for a good model. In the case of the other axles, we also included a gravitational dependence, as the center of mass is affected by the equipment mounted on the system. This turned out to be insufficient, since the dynamics of these roll and tilt axles are highly dependent on cables passing through the joints. Thus, the models, while still displaying much of the desired dynamics, are not as accurate as the pan axis. Initial tests at tuning the PID controller using these models were conducted with encouraging results.
And now we will go through some of our conclusions from our work and some suggested future work extending from our project. Our first conclusion is that to increase performance in roll and tilt, a model capturing the dynamics of the cables is required. However, the current models are sufficient for rudimentary control purposes, such as the PID tuning. The cables through the joints was found to be the major source of non-accurate models of the tilt and roll axis. And tests were done with the cables removed, and the results from this was in the same range as for the pan axis model.
Also, implementing the current algorithms is impossible due to their complexity and Newton's limited computational capacity. To counter this, more efficient methods and/or approximations needs to be developed. Some tests were done with such methods, with promising results, but requires further investigation.
And lastly, to improve the control, a more advanced method capable of compensating the nonlinear effects should be implemented. When a better model of the tilt and roll axis exists, it would be interesting to test MPC control of the system or something similar. Thank you for listening. And if you have any questions, please ask them at the poster sessions later. Goodbye.